Okay, so looking here, looks like we were just slightly off, uh, barely off right here, and it looks like we got the correct answer here. So I'm going to go through the formula, but then I'm also going to show you how to do it on the calculator. And if I were you, I'd probably do it both ways just to kind of double check everything. So we're trying to find the mean mu, right? And so we're kind of estimating that it's around where the sample was at. So it's going to be, we're going to estimate it that's 51, but then we're going to add and subtract um, our margin of error. And the margin of error is going to be the critical value times the, what we're going to have to do here is take the standard deviation and divide it by the square root of n right there, which is going to kind of be like it's called the standard error, kind of like the standard deviation for a sample of that size right there. So we're going to take 51 plus or minus, and so the critical value, that's based off of our confidence level, which is 98%. And so I'm going to go ahead and look up our table. And so I was going to mention this because you might run into this when you're taking the test if they don't allow you to take the table into the testing center. There will be links on the side of the test right here where you can click on textbook, or I'm sorry, tables. You won't have textbook, but you'll have tables right here. And so if you click on that, it will open up this table for you here. And so these are the z-scores, but I actually don't want the z-scores. So you keep scrolling down, and we want the student's t-distribution because we're dealing with the degrees of freedom. And in this case, let's see, the sample size was 34, so the degrees of freedom is going to be 33. So let me go back there. We're looking at degrees of freedom of 33 right here. And let's see, our confidence level was 98%. So that would mean that value right there, the critical value, is going to be 2.445. So 2.445, and then we're going to have to multiply that by the standard deviation of the population divided by the square root of the size of our sample, which in this case you use 34, so don't use 33, you actually use whatever n is. And I'm going to grab my calculator and figure out what that value is real quick. So let's see, 2.445 times 8.4 divided by the square root of 34. So I got all that in here. So that's going to be my margin of error right there. So they're going just one decimal place, so I will too. So 3.5. So we're supposed to add and subtract 3.5 from 51. So 51 plus or minus 3.5. And so when you subtract it, that's where you're going to get this right here. So 51 minus 3.5. And then when you add it, 51 plus 3.5, you're going to get the 54.5. All right, sorry if it got a little loud with the yard guys outside, but let's keep going. So let's go back to here. There was a part 2. So it says if the sample size were 55, would the confidence interval be narrower or wider? Anytime you have more data, it's going to narrow the interval because you'll have a better handle on that standard error dealing with the standard deviation, because you're dividing by, oops, let me go back to my formula so we can see it here. Right here. So you can see that you're dividing by the square root of n. So if that value gets larger when you dividing right here, it's going to shrink this margin of error that's being added and subtracted. So it's going to shrink the interval size right there. Now, real quick, there is a pretty easy way to do this in the calculator where you just put in these values. And so I'll show you that real quick. So if you were to go to stat, go to test, and we're going to do the t interval right here. And so then it defaults on data, but you want to go to stats because we already have the statistics here. Data, you'd have to put in the raw data. Okay, so X bar, let's see, that's 51. S was 8.4. And the sample size was 34. And then our confidence level was 0.98. And then go here, hit calculate. And it takes a while sometimes. There we go. So 47.47, but if you were to round to the nearest tenths, you would get 47.5 and then 54.5, so you can see it right there. All right, if you want help with any others, just let me know.